Welcome everyone to NSTA web seminars where you can find live interactive learning at your desktop. Tonight's presentation is titled Introducing the Next Generation Science Standards, and our presenter is Stephen Pruitt. We also have online with us from NSTA our Executive Director, David Evans, as well as Zipporah Miller and Ted Willard to share some additional information about NGSS and how you can access resources from NSTA. My name is Bryn Slate. I will be moderating, and Jeff Lehman is here to provide technical support. I'll just remind everyone before we get started that the NSTA Learning Center is your online portal for professional learning for science teachers, and we have over 10,600 resources available for you to check out, and a number of those are free. You can add them to your My Library so you can get to those when it's a good time for you. We also have community forums that you can connect with other science teachers and discuss issues, including the NGSS, with other educators across the country. Our online advisors are available to help you find what you're looking for there in the Learning Center. And we do have free tools that will help you organize your professional learning and demonstrate what you are doing for your PD. So do take advantage of those by going to learningcenter.nsta.org. And now I'd like to introduce today's presenters. First, we will have David Evans, our Executive Director here at the National Science Teachers Association. And then Stephen Pruitt will be our feature presenter. He's from Achieve. And Ted Willard will help us facilitate some Q&A. So you can submit your questions, and Ted will get those to Stephen for us. Zipporah Miller will be offering some information on NSTA's resources on the NGSS. At this point, I will turn it over to David Evans to get things started. Welcome, David.
Thank you, Bryn. Welcome, everyone. Really glad you could join us tonight. I see we have a nice number of folks who are participating right now. I'll make my opening comments really very brief. This is a wonderful opportunity for all of us who are interested in science education. It's seldom that anyone gets to be in the middle of the national agenda, but science educators are right now. We made it into the President's State of the Union message. A new emphasis on STEM education can be found in his budget submission to Congress. And perhaps just as important as that, American business seems to be strongly behind making improvements in science education. This is important because it means that not only are folks willing to talk about it and pump up the excitement, but in fact, folks are willing to put real resources behind their excitement these days. So with the release of the Next Generation Science Standards, I think we have a terrific opportunity to really move the ball forward, improve science education for all children, and really make a difference as we go forward. We're very fortunate tonight to have Stephen Pruitt with us. Stephen is really the chief engineer, I think it would be safe to say, for the entire process, from beginning to work with the National Academy and establishing the framework to his work with Achieve at trying to bring teachers, educators, experts of all sorts from across the country together to actually produce the standards. Stephen has done what I think to be a masterful job of producing a product in a way that gives us all strong hope that there'll be an opportunity for real adoption and acceptance of the standards across the country. From NSTA's point of view, we're really pleased to have been a part of the development process, to work with the National Academy, to work with Achieve, working with our partners at the American Association for the Advancement of Science, and we look forward to continuing this partnership as we go forward, as states begin to adopt the standards, and we all work on the process of how to implement them. NSTA will be providing professional development. We recognize that there will be a real need on the part of teachers to adapt their methodologies and to acquire some new information as the standards are implemented. We will be working on instructional resources, and right from the get-go, we will join Achieve and our other partners in advocacy to help states begin the process of adoption. Stephen Pruitt has terrific education credentials. He taught high school chemistry for 12 years. He joined the Department of Education in Georgia, had a number of important positions there. He was the Chief of Staff of the Georgia State Superintendent, and currently he's the Senior Vice President of Achieve, leading the NGSS development. And I encourage you to take a look on the website and take a look at Stephen's accomplishments. He, among us, is a very serious educator, and I think we really are grateful to all the efforts that he's made in pulling together a sometimes difficult, sometimes fractious group to produce a product that we can all be proud of and all be willing to stand behind. So without further ado, Stephen, let us have it.
Thank you, David. That was a very kind introduction. I really appreciate that. So I am very happy to be here. Again, I'd like to thank NSTA for this opportunity. Bryn, I don't have control of the slides, so if you need to give me that control, or if you're going to do it either one, that's fine. Just let me know which one. But as I said, I just really appreciate NSTA and David and the staff there giving us opportunity to come and talk to you guys and to continue this dialogue. NSTA is going to have a big role to play as we move forward with professional development and instructional materials, and I'm just very excited about the organization and its leadership there. I would like to go through my presentation. We'll stop at a couple of places and let people ask questions. I'm going to talk a little bit about what we've done to get here, and then how we have to think about this going forward. I would like to start off by just reminding everybody that this is the first step. We are working with the states and pushing the states to be very thoughtful and deliberate with regard to their implementation. And for a lot of states, that really means taking it slow. And what we're seeing is evidence that the states are really listening and that the states are having a slower implementation than maybe what they have done historically. And we want to do that because we want to ensure that states have the proper infrastructure to be able to implement these with fidelity. And so, so this is the first step. There will be other things to come. Eventually, assessments will be developed. Eventually, curriculum materials will be developed. But these were released last Tuesday, so we needed to. So now we'll be moving on to the next big thing to get prepared for the adoption and implementation. So for those of you who have seen me speak before, I'm sorry, you've seen this slide a million times, but the reality is this is an important slide. I'm not going to spend a lot of time on it except just to remind everybody that the process started with the Carnegie Corporation of New York funding the two-step process that started with the NRC taking the lead in developing the framework for K-12 science education, with NSTA and the American Association for Advancement of Science as partners, and then moved into the development of the next generation science standards, where 26 states came together to guide and to lead and to direct this process. We had 41 writers who took the framework and translated that into performance expectations in the standards. These 26 states are now going to give serious consideration to adoption. For those of you who are not part of a lead state, don't worry, or maybe don't get too excited, depending on your perspective. The non-lead states, it was not that they weren't interested. Well, some of them were not interested, but most of them opted to not be a lead state because this was not something that they did by paper only. There was some skin in the game here that some just weren't at a place that they could really do. For instance, besides having to guarantee giving serious consideration to adoption, they also had to name a lead, which some states did not have a lead science person at the time. They also had to convene broad-based committees. Those committees ranged from 50 to 150 people, and that was done at their own expense. So there were different things that went into the decisions about whether states were going to be a lead state or not. However, now that they're out, and actually in the last revision, we had a lot of feedback from the the non-lead states in giving us lots and lots of feedback. So really appreciate the work that you guys have done. Really appreciated the guidance that and the great working relationship that we've had with NSTA and with these lead states. If I could, I'd like to just take a moment, and Brent, I hope I'm not going to throw you off here, but we've got a lot of people online, and I would really love to see if you would just raise your hand if you had an opportunity to serve on a lead state review team or a non-lead state review team, or you just submitted any feedback to us either through the website or through your organizations or through your school, your district. I'd love to see a raising of hands of how many people did actually give feedback directly to the process through whatever venue you were attached. Could we do that?
Sure, Stephen, and lots of folks are raising their hand. It looks like we are at 30 and counting. A lot of hands going up. It looks like we're up to 33. People with their hands raised, now 34, so it looks like quite a few.
Excellent. Well, please accept my profound thanks. Really appreciate your willingness, your dedication to this. I really believe that this is something that all of you can say, this is our document. You have some ownership in this. I think that one of the things that when all this is said and done that I will tell people when they say, what are you most proud of, it's the fact that we did have so many people involved and so many different groups that supported this. And my extreme thanks to all of you and to the lead states and to NSTA for making this happen. So let's spend a little time talking about what's different about the NGSS. We're going to have to change how we think about some things in science education, and some of it's going to be quite comfortable. Some of it's maybe not, but it is really something that's going to be, that for things to be successful, we have to just acknowledge that there are some differences. So I'm going to start with just doing a quick overview of our conceptual shifts. Some of you have seen these before, but for those of you that may not have, these are some things that we really need to think about differently as we move forward. First of all, and I apologize, I should have said this before. Anybody on this call who has not read the framework, please go read it. And if you don't have time to read the whole thing, at least read the vision chapter. Everything that's happened with the NGSS would make so much more sense if you are familiar with the framework, which did lay out the vision and the content for science education in the 21st century. And it's really, the vision is one that is quite, I think, innovative, and it's one that I believe the NGSS have embraced. In fact, the National Research Council did a fidelity review of the standards. They are going to publish a version of the standards, or publish the NGSS themselves in print. To do that, they have to go through an actual review, and in their review, they deemed the NGSS to have fidelity to the framework. So we're very proud of the fact that the scientific community through the NRC has also said, yes, these standards would help meet the vision of the framework. So within that framework, there were three dimensions of science learning. There are scientific and engineering practices, cross-cutting concepts, and disciplinary core ideas. Scientific and engineering practices are, it's how scientists accumulate and communicate knowledge. Disciplinary core ideas, that's the content. That's the stuff that oftentimes when people think of science, they think of the content itself. And then there's cross-cutting concepts. Cross-cutting concepts are the things that connect different places or connect things throughout the year that can actually help kids make sense of it. Somebody's already asked, I saw, about how this would play out. And the vision for how this works out is that we teach kids to look for patterns. We teach kids the matter and energy we talk about in physics is the same matter and energy we talk about in biology, but it's through a slightly different lens. Some of what will come out with cross-cutting concepts will come out more as we develop additional products after this that focus a little bit more on the instructional activities. But the big part about the cross-cutting concepts is that is the cognitive connections. It's not additional content. It's actually how kids can structure things in their mind to make connections. So this first conceptual shift of those three dimensions, and the fact that kids are going to be expected to operate at the nexus, the interconnected nature of science of those three dimensions, kids are going to be expected to operate at that level. That means that they are going to be expected to behave that way in classes, in classwork, but also in the assessments themselves. They are not things that we can just kind of choose to forget. They actually are things that kids are going to be expected to show in context. Simply put, science and engineering practices by themselves are basically activities that really lead to very little or no learning. History of core ideas by themselves often end up being a list of facts. Putting the two together, especially with cross-cutting concepts, actually gives kids a context for learning that all of us that are science teachers, that's why we went into it, because it made sense to us. The second shift is the fact that next generation science teachers are student performance expectations. They are not curriculum. These are not activities to be done in classes. These are the actual things that students are going to perform to show proficiency. And again, I really want to focus on that word perform. These are performances, student performances. The three dimensions now become tools to use in the performance. The third item are that science concepts build coherently across K-12. That means we can't afford to leave things out at any grade band. It means that as you are preparing instruction, you have to know that where that content actually fits in a progression somewhere. You'll notice from the January draft that there was quite a bit of cutting that was done from within the standards from the January document. Part of that was done because there were things that were redundant, but also part of it was done to make sure that there was a very clear and crisp progression across time. And there were some things that didn't actually progress all the way through. And those things were things that we ended up cutting. The NGSS focus on deeper understanding of content as well as application of content. I read recently and heard also recently that if you add in a survey, people were asked about the sun, moon, and earth, and about 80% of the population surveyed knew that the earth revolved around the sun and the moon revolved around the earth. Now, it's kind of sad to think that only 80% of our country knew that. But actually another question came as a follow-up, and that question was, how do you know that? And that percentage dropped from 80% to 49%. So it was it was actually a pretty interesting fact about the fact that when we think about science education, we tend to think about it in facts. These standards are really designed to not just talk about the what, but also the how and the why. Science and engineering are integrated across K-12. Many of you probably already do engineering. What we want to do is make sure that we're calling it what it is. The lines between science and engineering have become more and more blurry over the years. So we just need to acknowledge that. Now, the flip side of that, though, is to be clear, these also shouldn't be looked at as another thing to do. They are easily integrated into the content. They are not designed to be these standalone things that you teach by themselves. They are things that are meant to be integrated. That's why you'll actually see performance expectations that have engineering in them within the traditional sciences just like you have the engineering design standards off to the side. Those aren't, and in high school, they are definitely not intended to be a whole other course. The NGSS are designed to prepare students for college, career, and citizenship. We had groups of almost 200 intro-level, 4-year, 2-year, and technical college instructors review the standards at different points in the process to identify whether or not the content here would prepare the students for success in college or career training. Really important that we did that. Higher ed has been at the table the entire time, and this was actually a very important step because it's not really ever happened before, at least in the area of science. But the other part of this is if you look at predictions about future career demand, you actually see, for instance, that there are 2 careers that are being predicted in the top 10 over the next couple of decades that are space science-based. We need more geologists and we need more petroleum engineers. But yet we tend to quit teaching earth science in high school, or at 8th grade, and we don't teach it at all in high school. So that's why you'll see these standards. They are very focused, but we also acknowledge that biology, chemistry, and physics aren't the only things that kids should learn in high school. And the citizenship component this is where the thinking component comes in. This is where we have to recognize that all of our students are going to be citizens of some country, and if they are able to think, they can establish their own politics, they can go in and make their own votes, not just because somebody decided that in not because somebody just, kind of arbitrarily said, oh, well, on the internet it says this, or somebody told me that, but they can actually seek out their own evidence and make their own explanations. Just so everybody knows, because I just saw this question, we had to release the standards in a PDF because we had states that are actually taking it to their state boards. We are working right now to put it up in the user-friendly database that we've had before, and we are working with NSTA to develop a nice interrelational database that people will be able to easily transfer to curriculum mapping software. And finally, the 7th shift is about is the fact that NGSS and Common Core state standards are aligned. So the science standards are going to require math skills before the kids were taught a particular skill in math or English language arts. We thought this was really important, and unfortunately, unfortunately, in some states, they actually did not speak to one another when those were being developed. Brandon, apparently we're having some audio skipping. Is that,
yes.
With me being on the phone, I don't think we had that last time. Is there some suggestions we should make?
I think if you're on a cell phone, it may be the reception of the cell phone. Are you on a landline or a cell?
I'm on a landline.
Okay. I will do some check into some things on the back here, but you're sounding okay now, so I'll just ask you to keep going, and if it gets too bad, we can find an alternative.
Okay, sounds good. So, again, these have been written as performance expectations. The 3 dimensions have been intertwined in a way that they can't be separated. Excuse me. They can't be separated when it comes time to, in particular, to test. It really provides a contextual application for students. And this is something that has been very important in the vision of the framework and has been carried out throughout the standards. There really is a focus on the how and the why as well as the what. Now, it's important, I think, that people know that we didn't come up with this idea just kind of off of a whim. NGSS are not the first group to ever think about weaving practice with content. In fact, we are continuing in some footsteps that have already started this. The framework laid this path out for us, but if any of you are AP biology teachers, if you look at the new AP coursework and assessments, you actually will see that they have been written as performance expectations. PISA, the new PISA assessment in 2015, which is an international assessment given to all 15-year-olds in participating countries, is being written as performance expectations. There are 2 major undergraduate biology initiatives that focus on performance expectations, the blending of practice with content. And even the scientific foundations for future physicians have bought into this and realized that it's better for future physicians to be able to practice as well as know their content. How do we know it works? Well, because there's research behind it. Things like Taking Science to School, Ready, Set, Science, Learning Science in Informal Environments have found that when you intertwine strands of proficiency, it leads to greater motivation and greater engagement, and it actually leads to greater content mastery. In America's Lab Report, the goals that they set were mastery of subject matter. They were developing scientific reasoning. They understand the complexity and the ambiguity of empirical work. They develop better practice skills. They have greater interest in science and science learning. Currently, the research indicates significant numbers of students, though, do not have a quality opportunity to engage in science and engineering practice. So some findings from this work found that a typical lab experience, which may or may not have anything to do with the actual content, intended to be more focused on cookbook type things, showed that content mastery was no better or worse than any other mode of instruction. Scientific reasoning was developed somewhat, and there was some evidence of increased interest. But when integrating those dimensions, content mastery increased. Students were able to develop a more sophisticated aspects of scientific reasoning, and there was strong evidence of increased interest in science and science learning. So it's important to note that scientific and engineering practices are not teaching strategies, or not just teaching strategies. You certainly can use them as teaching strategies, but they are not. They are actually outcomes just like the content. Again, remember I said these are student performance expectations, so the performance has 3 components. The science engineering practice is not just a cute way to do science. It actually is how scientists communicate and acquire knowledge. So it's really important that students are able to show that proficiency just as they would with the content. And it's also where the real application comes in. Here is an example of a state. This is pretty typical. States have a set of inquiry standards and a set of content standards, and teachers are told, hey, figure out which one goes with what, have at it. When the state test comes, you can guess that usually the stuff on the left gets dropped off, or it's tested in isolation, which means that you're just testing kids on whether they can read meter sticks or graduated cylinders often. Or the states have double coded, which means that as teachers you don't really know what gets coded with what. And so the design of this is to be very clear about the student outcomes, and so that you as teachers know exactly what your kids are being held responsible for. Let's take a little closer look. If we look at this set of standards, this is from middle school, Structure and Properties of Matter from this same state. I'll call your attention specifically to the verbs: distinguish, describe, recognize, and identify. From a cognitive perspective, we're not asking a whole lot of these kids, especially when, and even when you put that in context with the content itself, the content that's listed here is not challenging content, really. But if we look at the NGSS, again, I want to point you to the verbs. Develop molecular level models, design a solution, develop a molecular level model that depicts and predicts, develop molecular models, analyze, interpret, gather and communicate, design, construct, and test a device. These are very definitely performances. Also, if you look at the content that's associated with these, it's a much more robust need for students to be able to, or requirement on students to be able to display. I hope all of you have seen the architecture, but just in case you haven't, this is an example from first grade. You will see that 1-LS1-1, that is a performance expectation. It's what many states will call a standard. That is the accessible component. So use materials to design a solution to a human problem by mimicking how plants and or animals use their external parts to help them survive, grow, and meet their needs. It's an engineering aspect, but it also has a very clear content requirement. There are also in red clarification statements, because sometimes you just need a little bit of extra words to make things even more clear or to give examples. So that's where we put examples. And then there are these things called assessment boundaries. This particular example doesn't have that, but assessment boundaries are not meant to limit you in classrooms, but they are meant to limit what kids are held responsible for at a particular grade level on large-scale assessment. So, but also it's meant to guide you. Most kids based on the research we have, there's a bulk of kids that these assessment boundaries can actually help guide you with the level that kids should be doing within your classrooms. Now, I'll be the first to say this is more complex than what we have in most state standards. But the reason for this is to support teachers and to support curriculum developers. Typically when you get a new set of standards, of course, teachers are told, okay, unpack the standards. Well, the reality is we had to pack the standards to write them. So the blue, orange, and green box, these are what we call foundation boxes to the performance expectations. So when it says use materials to design a solution, there's language in the blue box that tells you what it means to design a solution. The orange box, those are the disciplinary core ideas, and they tell you what content kids are responsible for. And the cross-cutting concepts give you the way you can connect this to other things through the cross-cutting concepts. We wanted to try to negate as much unpacking as possible. Obviously, when you start unpacking for instruction, there are some you will have some flexibility in how you do that, but these are the things that actually you need to understand better what those performance expectations are. At the bottom of the page, you'll see what we call connections boxes. These we are working on and will be released by the end of the month. They are, in particular, I'll focus on the last one, which are the common core connections. So those of you who, in particular, are K-5 self-contained teachers, we wanted to be able to have one document that you could look at and go, okay, I need to know this math skill or I need to use this math skill. Sometimes those math skills come the year before, but sometimes they are in the same year. It gives you an opportunity to actually mesh the instruction of math and science and English in a much more effective way. You'll also notice that along with the standards on the web page, nextgenscience.org, there are a list of appendices. These are designed to support and to give additional clarification to the standards. I encourage you to read them when you get a chance. A couple of places I want to just point out. All Standards, All Students is an appendix or a chapter that we're particularly proud of. We believe that this is going to be something that can be really helpful to all the users of the NGSS, but also that was very useful as the writing occurred. We had a whole team that was dedicated solely to focusing on equity and access. They did bias reviews of the standards to ensure that the language was not biased They really held us responsible for consistency of language in the later drafts. But the new part about this is there are 7 vignettes or 7 case studies that take 7 different subgroups of students and really lay out a vignette for how you could engage students in learning, especially those who have various needs. So what you'll notice are that you'll notice the No Child Left Behind subgroups, but also you'll notice that we've added 3, gifted and talented, gender, and alternative education. All of those case studies are going to be included in this chapter, and I believe it can be a real benefit and a real boon to you as teachers as you see kind of how this is meant to happen in classrooms. Appendixes E, F, and G. These appendices are not meant to take the place of the framework, but they actually take issues in the framework of these 3 areas and focus them more so on the standards. The progressions actually take the grade band endpoints and somewhat recast them so that it's a little bit easier to follow the progression. The practice appendices F and G, what you'll see there that's not in the framework are the progressions of each of the practices and each of the cross-cutting concepts across time. The framework committee was not able to get that done, so we needed to do it when we developed the standards. And so those are there for your review. Appendix K are model course maps. Those we released in January with the initial draft. They're going through revision now and should be out by the end of the month. We are also, and as I'll mention again later, going to be doing additional model course maps. Hopefully a lot of you saw Appendix L, which are the connections to the Common Core State Standards in Mathematics. In the final draft, again, which will come out by the end of the month, you will see that that's been expanded to high school and expanded into all the areas of the content. And Appendix M is a new one, and those are connections to the Common Core State Standards in English literacy, in English language arts and literacy. So, my friend Ted, it might be a good time to take a few questions.
That sounds great, Stephen. Got several that have come up here. Let's just start with one from Doug here that ties into the Common Core materials that you've been talking about here. He's wondering whether Common Core standards will be adjusted, or someone will add onto the Common Core to show connections into the science disciplinary standards.
I have no way of knowing that. That's not my decision. I think that you may see that in Common Core. My guess is you probably will see more of that at the state level, where states are actually doing that. We, I think, are going to give a really big, in those 2 appendices, I think there's a really nice connection, but we're actually even looking at doing some additional things to make those more robust in some future documents that we're looking at.
Great, and I think here's another question, which I think the answer is the states will decide, but Teresa asks, are the assessments being worked on since the standards are now final? Will the same grades be tested for science?
So we just finished the standards on last Tuesday. We just, literally, when we released them, we had been working on them all day. So we have not started working on the assessments, and Achieve would not be doing that anyway. There are several things that have to begin. One, states have to adopt them. If states don't adopt them, then assessments of these standards would be silly to work on. The good news is we have a lot of states that appear poised to do that. We actually have had 3 states already take these to their board to initiate their rulemaking procedures. But one of the things that we will be working with states on are their timetables, and we are going to help them work together on developing things going forward, including assessments. As far as the same grades to be tested, it all depends on what happens with Congress, and we all know how effective Congress has been in making decisions of late. But that's not a decision for me. That's a decision that the reauthorization of the Elementary and Secondary Education Act will have to do.
Great. Just was looking. So Becky asks, the middle schools are grouped. Does this mean we'll repeat each of these in all grades, or will the states divide them further?
Yeah, there's no way you could do all of these every year, because if you did, kids wouldn't learn a whole lot. They're grouped this way because we literally have a third of the states who teach middle school as discrete courses. They have a year of Earth, a year of Life, a year of Physical. We have a third of the states who do integrated science, and we have a third of the states that just let districts decide. So we had to write them as middle school standards. We have given in those model course maps different suggestions about how you could arrange those, but states will ultimately make that decision, or districts, if you're in a state who the state doesn't make that kind of decision.
Great. Thank you. A question that came here earlier, I thought was interesting. What do you mean by internationally benchmarking the standards?
So internationally benchmarking, what that means is that you pay attention to what's going on in the top performing countries. Achieve did an international benchmarking study that was delivered to the Framework Committee at the NRC, where we reviewed the top 10 performing countries in PISA. And in doing so, we did a review of their standards. We did a review of the things that seemed to work, the things that did not seem to work. And all of those recommendations went into the framework and have come to fruition here. The other part that we're very happy about is that as we've had more and more discussions with the individuals who are responsible for developing the PISA assessment for 2015, they feel that we are in a much better alignment using these sets of standards than what most states have had historically.
Great, thanks, Stephen. So I had a question about engineering, and someone trying to understand it. They said it seems to be a natural fit with high school physics, but how is engineering experienced within the context of high school biology and chemistry?
Oh my goodness, there's so many opportunities. Bioengineering has become huge. You know, if you look within those standards, you actually see places where kids are asked to design a solution based on the properties of pure substances. There are places where kids have to construct solutions to problems about how environments are impacted. So all those, so there's lots of opportunity, but this is also an area we're going to need a lot of professional development in for high school teachers to really see how to implement these effectively. Again, that's one of the reasons why you see a separate set of engineering design standards now. Is the feedback that we got was there was just too much crammed in there, and we needed that extra set to really draw it out and show that very clearly. Ted, I also want to just make one comment. I see where people are saying that that the NGSS will fall on the PARC exams or the Smarter Balance exams. PARC and Smarter Balance do not assess science. I want to be very clear about that. They assess math and English language arts. There is a reading in the content areas, but that's not the same thing as science. So just want to be really, really clear about that. That new assessments will have to be constructed. They may be based on the same consortia. They may not. It may be that we have states that were in PARC and Smarter Balance and some that weren't in either. They come together to develop new assessments. But that's a little bit farther down the line.
that ties into a question here about, just in generally about accountability, and a question, how effective would those standards be without accountability, or what sort of accountability seems to be necessary to make these standards effective? If I could twist the question around a little bit.
So that's again, I'll talk about this a little bit more in a little while, but we are going to be forming the NGSS network, which is going to be for states who adopt the standards. Policy discussions around science have not really happened a whole lot. The focus tends to be on math and English, and the states who adopt these standards, we're going to work with those states to come up with a list of policy recommendations and push the states to adopt those. So that's something that's coming. But here's the thing that everybody needs to know. At this point, there's been roughly 34 waivers granted by the U.S. Department of Education in terms of the No Child Left Behind legislation. Within those 34, 18 have included science in their accountability structure. And there's actually about 5 more who have but did not report it to the USCD, because we won't get into the details, but they actually only have to report on their system. They actually don't have to report on what's going into that system. So states are realizing the importance of science, the importance of STEM in accountability, and I believe that that's coming. And when I left the Georgia Department of Education in 2010, there was only one state that had it written into their both their Race to the Top application and their intent to the U.S. Department of Ed. There's only one state that had science as part of their AYP. I'm happy to say that was actually my state, but we were really glad that happened. But now we're seeing half the states who have applied for waivers. There's a lot of states who have applied for waivers, but they haven't been ruled on yet, so we haven't been able to read what those are and what their intents are, but it sounds very much like science is going to be very prominent. I think just one last question here, Ted. I see. Actually, no, we've already answered that question. Do you want to do one more, or are you ready to move on?
I was just going to throw one more in here that came back from a little bit ago, just for some further clarification. Someone said, did you say that NGSS does not need to be impact? What about determining depth of knowledge?
Wait, say that again?
Sure. Someone, and I think they were correct, heard you say that NGSS does not need to be impact. And their question then was, what about determining the depth of knowledge of the standards? And I believe this is one of the maybe Norm Letterman's approach of looking at standards. I'm trying to remember who does the depth of knowledge framework.
Norm Webb.
Norm Webb, that's what I meant, sorry. Yes.
Yeah, so the depth of knowledge that has been done historically has been done based on cognitive verbs. And I can tell you that if these are done well, your depth of knowledge, I even saw somebody chat in that a lot of depth of knowledge in a lot of state standards had a DOK of 1, and NGSS is really going to require 2s and 3s. So we are pushing on new psychometric models. And when I say unpacked here, when unpacking for instruction is one thing. What we don't want to have happen is people try to interpret what was intended. But that's where the unpacking gets very dangerous. Unpacking for instruction, obviously, there's local context and everything else that you would want to put in there. But when it comes to large-scale assessment, the standards are what they are. And those standards are what would need to be assessed. And I can assure you that the difference in distinguishing and recognizing and identifying versus constructing a model that predicts or constructing an explanation, because that's not explained like a cognitive word explain. That's constructing an explanation based on evidence. That means that you can say, we know that the moon has these phases because of the positioning of the Earth-Sun-Moon system. And here's the evidence of that explanation. That's a very real difference in cognition to what we have seen up to this point. And it'll be interesting to see how the psychometricians go at this. I think that Norm's work on depth of knowledge will be able to be translated, but it's going to need a little bit of work, frankly, because, like I said, these are performances, which is something that we've typically not seen in large-scale assessment.
Great. Why don't we go on now, and we'll do some more questions at the end.
All right, glad to. So let's talk a little bit about what should the NGSS do and what will they not do. These are also some more instructional type shifts, if you will. First of all, going back to one of our original conceptual shifts, the standards describe achievement. They do not describe instruction. They articulate a clear vision of the learning goals. They articulate the student performance at the conclusion of instruction. These are not a description of curriculum. They do not dictate instruction. And if you try to just simply take these performance expectations and do them as activities, I can assure you that your students will not understand what is outlined in the foundation boxes, and they will not perform well once large-scale assessment comes. These aren't just a list of activities. They are the performances that students will need to do after instruction is over. Successful implementation at the classroom means that the classroom instruction is going to need to reflect the coherence that was shown in the framework and in the NGSS. So what that means is that we can't continue to think about, and some of you on the phone, or probably a lot of you on the phone, don't already have made this shift. But thinking about these as individual discrete pieces is not where we're headed. Effective implementation or successful implementation means that you're going to take these three dimensions and really integrate them and give kids the opportunity to do that. Also, it means that you will construct units of instruction that bundle performance expectations into coherent lessons and assessments, but not teach each thing one at a time. To be unsuccessful, we'll do what we've been doing for the last 15, 20 years, where we teach the three dimensions totally separately and expect kids to somehow miraculously make the metacognitive jump to connect those. And also to treat another unsuccessful implementation will reflect individual practices and performance expectations as standalone lessons or units. If you just look at, number one, number two, number three. Number one takes 2 weeks, two takes 2 weeks, and three takes 3 weeks, so that's 7 weeks. You don't really stop to develop a really high-quality connection to the disciplinary core ideas and see that actually those three things can come together into a coherent instruction. We'll be defeating the purpose. Teaching these one at a time will not help kids create in their mind a cognitive or conceptual model of how the world works. So these things are going to have to be bundled together. Quality instruction means that we're going to be able to effectively use the practices, the cross-cutting concepts in the context of the content. So pairing a specific practice with content was necessary so that we could define a discrete set of blended standards, so that people couldn't decide, well, I'm not going to do any practices, or I'm not going to do any cross-cutting concepts. I'm just going to do the content. But they should not be viewed as the only pairing. Quality instruction means that, and you'll hear more about this in upcoming time, but NSTA and a set of states and Achieve are working on developing a rubric that can identify and can help teachers identify quality instructional units. Within that, you'll see that it's not really a quality unit if you only do the practice that's there with the content. There should be a blending, or building rather. The other thing is that we just have to realize the practices are inextricably linked. I really have a hard time understanding how a person thinks they could plan and carry out an investigation and never collect and analyze data. Or they could construct an argument based on evidence but never ask questions, or never construct a model that explains that argument. or never collect information. Those things are linked, but in the standards themselves, those performance expectations, we have identified the practice that would be sampled or highlighted within that performance. So let's take a minute and talk about what it's going to be to move from standards to instruction. When we start to build instruction, and when I say we, I mean teachers, we build toward the performance expectations. Those aren't, as I said, those aren't the instruction. We want to build toward those. We want to build the scaffolding for kids to be able to build toward those so they can perform those at the end of instruction. This is an example from the appendix with the disciplinary core idea progression. The reason this is important is because if we continue to teach science in a way that doesn't connect things back to a central core idea, kids won't be able to make the connection of what that big picture, that big idea is. So here is an example of structure and properties of matter, where these are the concepts that kids should be able to do or explain as they progress across time. And this is where the whole idea of coherence and bundling come in. So here we have middle school. This is from Structure and Properties of Matter, or Matter and its Interactions. And what you see in the kind of, I don't know what color that is, I guess peach box, the fact that matter is composed of atoms and molecules can be used to explain the properties of substances, that is actually from the progressions table. That's one of the big ideas that we want to tie things to. And the standards underneath there, the performance expectations, those are performance expectations that were written specifically to help kids understand that content. The same thing can be said for the things on the right. Now, the thing is, because of how the standards are written and because of the fact that they are written and intended to be coherent, part of that coherence means that they can be bundled to make, and they need to be bundled to make sense, but they also can support other ideas. So, for instance, MSPS 1-2 actually also supports, not only does it support that matter is composed of atoms, it also supports that reacting substances are rearranged to form different molecules. Just like MS-PS 1-5 mainly supports the idea of reacting substances, but it also contributes to the idea that matter is composed of atoms. Now, the other thing I want to point out to you very quickly here is within these 6 performance expectations, you'll notice that there are 4 of the 8 practices that are sampled. Across all the performance expectations, you could get all 8 practices. But when you build instruction, you don't want to have to rely just on those 4, but you want to build to those 4. So bundling, it's what's for understanding. Trying to teach individual performance expectations have led to a disjointed and stunted view of science. It's what I call lemon and snicket science. It's just a series of unfortunate events. And there's nothing that's coherent and helps the child see the big picture or the story. Metaphorically speaking, we've talked about the fact that when a kid walks across the stage of graduation, they can look back and see the story of science that's been laid out for them. So as we develop instructional materials and instruction, they should be viewed as leading to understanding a larger core idea, not just the little pieces, but how those little pieces fit into the bigger picture. Students, we know there are some who can make that jump, but we have to provide the environment for them to be able to make that metacognitive jump. That's why this idea of bundling, it's why this idea of the progressions, and frankly, it's why the science and engineering practices are so critical, because they have to place these ideas into explanations, arguments, models, investigations, and when they actually are engaged in doing that, they can develop that metacognitive connection between things to see the bigger picture. Coherent instruction and instructional materials and instruction focus on a disciplinary core idea or set of them rather than discrete pieces that are never tied together. I was a chemistry teacher, so here's an example of if I was going to develop a unit in chemistry. I'd also, my point in showing you this is you don't have to teach just the disciplinary core idea by itself. There are things that are connected across. So if I decide I want to do something on conservation, interaction, and matter, I could select these 5 standards from PS1, this one from forces, and one from energy. And together I could develop an instructional unit that is robust, that a student at the end of this could understand that matter is made up of particles, forces act on matter, and energy is a driving force within matter. So this is actually a nice representation of how you could do that. I'll also interject at this point, those of you who are reading these, make sure you read the standards as a whole, because if you're looking for a particular thing, it could be that it's actually in a different section. So here's an example. As a chemistry teacher, I always thought it was really important that kids understood that elements heavier than helium came from stars. Well, you won't find that in physical science. That's actually an earth science standard. You'll notice that there are standards in matter and standards in energy that actually support life sciences. Again, all those things really come together in a way that can present a great picture for kids. So, future support for NGSS. I joked at NSTA. I did not get fired last Tuesday. NSTA has lots of work to do going forward, but some strategies that we're going to be working with states on from an Achieve perspective are that we are going to form an NGSS network to support state adoption and implementation. States who adopt the standards or who have serious plans for adopting the standards will be invited to be a part of that network, and a big part of that network is the development of policy recommendations and helping the states have collective conversations around implementing these standards in an effective way that has fidelity to their intent. We are going to work with states in clarifying and communicating the meaning of college and career readiness, STEM readiness with respect to NGSS, working with our higher ed partners as we continue to think through that, provide tools and guidance to states as the field builds capacity to deliver NGSS in the classroom. Building capacity is probably something that we've seen with Common Core that we need to spend more time on. I know everybody wants to get to the assessment, but we have a very unique opportunity with science that we're pushing the states to be slow with this implementation to make sure they've built the infrastructure, but also to make sure they do a good job of implementing Common Core. If they do a good job of implementing Common Core, science has a better opportunity to be successful. But it also gives us time to develop materials, to develop tools, for NSTA to put into full force the professional development that they're going to do. We have the opportunity of time, and we need to use that time to build capacity and focus on having people really have quality instruction and support for quality instruction rather than immediately trying to write the test. How novel that we actually focus on teaching and really supporting our teachers. I think we have a unique opportunity. We should grab it. We'll also be working with states around accountability and assessment, helping them think through those issues. Again, these are both issues that have not been discussed across state lines with science. They've been discussed with math and English for years, but science will be new. We also are going to support states around communication and coalition building. So some immediate steps that are coming in the next year. Achieve and NSTA and NRC are all going to be supporting state adoption. State affiliates for NSTA, I'm sure, are going to be mobilized. We are going at Achieve through the network and through the lead states that have already been working together, and now through the building capacity for state science education. We're going to be helping states think through their plans for adoption and implementation. We, in addition to the 3 course models that are being revised that were shared in January. We're going to be adding additional course maps, including how to accelerate to get kids to AP and IB courses quicker, and some overlays with CTE pathways. A very exciting project that we're working on with NSTA. NSTA is lead partner with several lead states in developing a rubric that we call Educators Evaluating Quality Instructional Products. This rubric will allow NSTA and states to evaluate instructional materials with a common definition of quality. There will be a lot of training that goes along with that. It'll be things that'll be opportunities and open for you to use. It's a very exciting idea, and part of that idea is really to build a better consumer. When somebody tells you this is a good unit, you want to, if we have a common definition of quality, we can do a better job of determining that. That is something that's under development. It's not going to be too long before it goes out, but it's not quite ready yet. Part of this kind of work is to have what's called interrelated reliability, where different people can use the rubric and get the same results. And so NSTA is going to start using the rubric, I think, fairly soon to start evaluating products that they have. And as they do that, they're going to say, hey, maybe we should have written this a little better or a little differently. States are going to do the same thing. So that'll come out eventually. Publishers' criteria is something that the writers of the NGSS will be working on to communicate clearly to publishers. This is what is expected in the new generation of textbooks and curriculum materials. Somebody asked me in the last session when I expect publishers to come out with new stuff. And, they're already claiming, not all of them, but there are some who are already claiming alignment. And all I will say to you is we released them last Tuesday. Think of the logic of that. But at the end of the day, it's really about you guys. You guys are the consumer. And if you demand that they do a good job and you don't buy products that are not aligned and that are not quality, they'll find a way to become quality. So I really think that's where the power of teachers comes in. And then we will be developing some model curriculum frameworks, again, not specific frameworks that everybody has to use, but just some models that people could use. And seriously, I just really want to say thank you. We had, I think, a lot. I think we ended up with like 37 of you, and some of you joined late, that had a part in giving us feedback directly. The thing I'm most proud of are the number of people who were involved in this process. I'm proud of the fact that I've been able to be a partner with NSTA in the work that they've done, and will continue to do. So I just want to say thank you to all of you who took the time to read the standards in the public drafts, to participate on your state leadership and review teams. I really believe this is something that you can all claim ownership on. These are not standards that somebody else owns. These are standards that science teachers can own and should own. So I just really want to tell you thank you for all the work that you've done. I was noticing earlier that a lot of congratulations and thank you from the Vermont team. And Kathy and Gail have done a great job of marshaling this thing through Vermont, and they're just one of the 26 states, but well done to all of you. Thank you so much. This is my contact information. I'm always happy to answer emails and answer questions offline if you like, but I think we have time for us to take some questions.
Yes, we do. Thank you very much, Stephen, for all the explanation you've put in here. I've got a bunch of questions I've tried to save up here. I've been going through. I had a question early on. To what extent did the International Baccalaureate and Middle Years and Primary Years programs inform this development?
Well, especially in the framework development, the framework was developed using Standards for College Success from College Board, which led to AP. There were reviews done of most successful states and of IB programs. So This has been something that's been ongoing, and it wasn't discovered or developed in a vacuum. It was with the intent of ensuring that students can be successful on NAEP, in IB and AP, all of those different avenues.
Great, thanks. Another question here, specifically it said, how will NGS address this? But I think it's talking about in terms of just the adoption process. How will we address the bridging the gap between old standards and the new standards for current students in order for them to be successful going forward? So I think it's meant to transition.
Right. So that's a great question. And you know what? I wish I'd talked about it in the first session too. Let me tell all of you here, and you can quote me on this. Crosswalks will be the most dangerous thing that can be done in this whole transition because it undermines the cognitive shift that these standards require. We already are seeing where people are trying to do crosswalks and saying, oh, well, they had ecosystems in 4th grade and now they're in 3rd grade. Well, that's only part of the story. We are going to work with several groups to develop some criteria to look at in making that transition, but please, people, do not do a crosswalk. It just will absolutely undermine your understanding, your teacher's understanding. Your principals will think, well, this isn't that big a change, when it actually is a significant change. The other part that I'll say is the states are really thinking this through. I mean, we are seeing states who are actually considering not doing a K-12 implementation, but actually doing a K-3, 6, 9 implementation, so that they can actually build toward rolling it in over time and focus their resources on different teachers and that sort of thing. But it really is something that I think is a really important idea here, that we don't just simply say, let's just do what we've always done.
Great. Continuing this idea about implementation, the first point here is, do teachers, especially at the elementary level where they also teach other subjects along with science, really have the time and background to design next generation instruction as implementation begins?
Well, the thing is, we can't design standards based on where we are, because that's what we have standards for now. And so, if we do we need professional development? Sure. And let's not fool ourselves. It's not just elementary teachers that are going to need support. Teaching this way at the high school level is going to be very different. I mean, frankly, it took us 6 months with the writers to get them to really narrow in on the difference between argument and explanation. I mean, that's a significant difference. So do they have the time? Sure, they have the time. Again, this is where the policy conversations are going to have to occur. This is where we're going to show examples of how to work the science into the day and how to mesh that effectively with math and English. But the fact that a teacher who maybe hasn't had the science at this moment in time doesn't mean that they won't have plenty of support by the time these are implemented in 3, 4, 5 years. But again, we can sit and talk about where we are right now, but these standards were really designed to put stress on the system, and this is where we're going to have to really put some time and effort to making sure that all of our teachers are prepared and supported for success.
Great. Keeping this theme of support, another comment here. As a pre-service science teacher educator, I grapple with how to get my students to understand how to do this in a state where this type of science is not widely seen. Is anyone working on instructional materials to help students conceive science in this manner? Will videos of NGSS-style science teaching be made available?
Eventually, all of that is true. In fact, I think Ted has told me before that they are looking at videos. The writers have actually started talking about how they can start doing some videos. Instructional materials will be developed, but let's be clear, we don't have tons of states where this is going on anyway. So you may be in a state that's not too widely in your state, but you're not alone. Again, this is why it's going to take time. This is why we've really pushed with the states. You can't adopt this and expect to implement it a year, maybe even 2 years later. We really have to think about this differently and recognize that we need models. I think that was actually one of the areas where in Common Core, one of the lessons learned was the fact that there wasn't enough time spent on developing those models. We went straight into developing tests, and that's why I say I think here's our opportunity to focus on instruction and focus on good materials that can support teachers as we move forward.
Great. Another question here. Do school sites wait for the district state to implement, or do we have a voice in curriculum development?
Sorry, Ted, could you repeat that?
Certainly. I think they're basically saying, do school sites, should they be waiting for their district or state to implement something, or do they have a voice in curriculum development? Should they start doing some work themselves?
I think that if you teach a group of kids, you have a right to have a voice in anything that affects those kids. But I would also say that you need to make sure you're properly prepared to do so. It just kind of depends. I think a school, a district, even before, in fact, we've already heard this. We've heard of some rather large districts, actually, who aren't going to wait on the state to adopt. The district's going to go ahead and adopt them, and they're going to go ahead and start professional development. I think it just depends on the type of district and what you're allowed to do. Obviously, if there's a state test where there is some accountability, you don't want to put your kids in jeopardy. But there are things that can be started now. Having a deep understanding of the practices and finding the cross-cutting, the NGSS that would naturally support the science that's in your current grade, sure, I think you could go ahead and start developing those materials. I just would caution that, you know, when you first start, you just need to know that it's probably not going to be perfect. Like I said, we actually spent 6 months with the writers just getting them all on the same page in understanding the framework before we ever even started putting pen to paper, because that's a big lift.
Absolutely. Great. One more question here. Do you see the traditional high school sequence of courses, biology, chemistry, physics, as changing to a more integrated science, science 1, 2, 3, and 4 for each year of high school?
That'll be totally up to the states and the districts. You know, to do that, obviously there can potentially be some licensure issues and so forth. NGSS does not take a stance on that one way or the other. When you look at the actual course maps, you'll see where there is one that's what we call a progressions map, where we do actually see a more of an integrated approach. But you'll also see where there's a domain specific. And you'll also see where there's a modified domain. So what we want to do is lay out the cafeteria that would support quality learning of the NGSS, and trust that the states and districts are going to do the things that are going to be best suited for their local situation.
Great. I think, fine. We should be wrapping up here. I want to clarify one comment, or just pull some from here. Someone had asked a specific question about Massachusetts and the MCAS, but basically, if states choose to adopt NGSS, they're going to have to make changes to their assessments. Is that an accurate thing to say?
Well, yeah. I mean, you can't assess kids on things they haven't had opportunity to learn. So now, I'm not saying that Massachusetts is going to get rid of the MCAS. We don't know what's going to happen with you know, whether they're going to change names or whatever. But what we do know is that states currently don't have state science assessments that support this type of assessment. So there's going to be a lot of change that will be coming. Again, this is why we're saying it's going to take time. Even developing assessments like this, some of you may have been in sessions with me before where I share an assessment task called lake algae. That assessment item alone took me about a week to come up with, going back and forth with a colleague of mine. But it's going to take time to do that. So I don't think you need to say, oh, well, they're going to get rid of MCAS or they're going to get rid of whatever. What you need to know is that the state assessment in science is going to have to change once they implement. Now, again, this is important. People get adoption and implementation mixed up. Many states are going to adopt. Well, I probably shouldn't say many, but we're anticipating a lot of states will adopt in this first year. But none of them are talking about implementing very quickly. But the way a state works is they have to adopt so that they can start aligning resources, both financial and intellectual resources, to begin the work, because they can't work on things that aren't adopted. But it doesn't mean they have to implement right away.
Okay, great. Thanks, Stephen. We'll go ahead and wrap up here and take maybe a few questions after we complete the survey. We'll turn it over to Zipporah Miller.
Thank you so much, Bryn, and I would like to take this time to thank Ted, and especially thank Stephen Pruitt for everything that he's done in this effort and working with the states in the development of the standards. And with that said, I want to just offer a few resources that are available to you. And I'm going to start with the websites, the nextgenscience.org and NSTA.org/NGSS. We also have available to you an portal in which you can collaborate with your colleagues not just within your state but across the country, on the NSTA Learning Center, and we have an NGSS discussion forum. In addition to that, starting this Thursday, we're going to start our online short courses, and we're starting with one which is going to feature Paige Keeley as the instructor, and it's going to be a 3-session short course with assignments in between. And then we'll also have one on engineering, as that has been a popular request to see what is engineering going to look like in the classroom. We have been conducting web seminars on the scientific and engineering practices, which are archived in the NSTA Learning Center. And currently, we are going through a series of web seminars on cross-cutting concepts. Coming next, April 30th, Energy and Matter, Flow Cycles, and Conservation will be our next cross-cutting concept. If you missed us in San Antonio, we have another conference coming up, and this will be the STEM Foreman Expo, and that will be in St. Louis, Missouri. And Stephen Pruitt will be joining us in St. Louis, and he will be doing a session where we'll talk about the connections between Common Core and the next generation science standards. In addition, we will have a lot of rich sessions, some led by NGSS writers, and also led by individuals who were involved in the development of the framework. What do we have available in print? Well, we currently have the framework still available, and Stephen Pruitt does urge everyone to read the framework, as that is the foundation for the development of the standards. We have a reader's guide to the framework also available at the NSTA store. For those of you who may not be aware, the National Academies will be printing a print document of the standards, and it will be available this summer. And you can order a copy from the NSTA bookstore. In addition to that, just released is the Reader's Guide to the Next Generation Science Standard. That is available in electronic format right now, but also will be available in print. Last but certainly not least, we will have conferences on the East Coast and West Coast, and that will be this fall. and this coming spring, and we will feature strands and sessions on the next generation science standards at the area and the national conferences. If you have any questions, please feel free to contact any of the NSTA staff involved in this web seminar, and I will turn it over to Bryn.
Well, thank you so much, Zipporah. I want to thank you for sharing that information about the great NSTA resources, as well as our other presenters this evening, David Evans, our Executive Director here at the National Science Teachers Association, and a big thank you to Stephen Pruitt for Achieve. Fantastic to have that overview tonight, and thank you for all of those great responses to our Q&A. A thank you to Ted Willard as well for helping to facilitate that. We would also like to thank the sponsor of today's web seminar, the Carnegie Corporation of New York. And a thank you to the administration of NSTA for their support for web seminars. Here's a look at our upcoming web seminar calendar. Tomorrow you can join us for one in our NASA Explorer School series, Engineering Design, Forces in Motion, Balloon Aerodynamics Challenge. And then later tomorrow evening, Introduction to Biology, The Secret of Life, Pedagogical Implications, Discussion 2. And on April 18th, join us for Properties of Living Things, Searching for Fingerprints of Life on Mars. You can register for these programs and more by going to learningcenter.nsta.org/webseminars. Thank you everyone again for your participation today, and we do look forward to seeing you again on another web seminar.